The amount of air entering the engine must be measured, so that the amount of fuel injected into it forms a mixture to suit the engine operating conditions at that time. The volume of air entering the engine varies according to the position of the accelerator pedal and the engine speed and load. Changes in volume are reflected in changes in manifold pressure between the throttle plate and the intake ports. When the pistons draw air away from the manifold more quickly than air can pass the throttle plate into it, the pressure in the manifold falls. At idle speeds, this pressure is low. A high depression or a vacuum exists. As the throttle plate opens, the pressure approaches that of the atmosphere. The depression or vacuum tends to fall in value. Devices measuring air entering the engine send a varying electrical signal to the ECU. The signal can be a measure of the volume of air or of the manifold pressure. In both cases, this information is combined with the engine speed signal to provide the basic setting for the injector pulse width. An airflow meter measures the volume of filtered air entering the engine. It can be mounted on the air filter casing or close by. All air entering the intake flows through the meter, then through a sealed flexible hose or duct to the throttle body, then enters the engine. Vane-type airflow meters have a spring-loaded vane or flap, which deflects according to how much air enters. The electrical signal to the ECU varies with this deflection, as contacts attached to the vane move across a potentiometer. The intake system must be airtight, with no leaks downstream of the meter, otherwise inaccurate signals will be sent to the ECU. Manifold pressure sensors measure pressure in the manifold. One common type has a small connecting hose from the manifold to a sealed diaphragm within the sensor. Changing manifold pressure alters the position of the diaphragm and the pressure it exerts on a sensing resistor. This provides an electrical signal relative to the manifold pressure, which is sent to the control unit. Other devices can also be used to provide the air measurement, but all result in an electrical signal to the control unit. Variations in air density, according to temperature, are measured by the air intake temperature sensor. It's installed in the main passageway, protruding into the airstream. During cold starting, the engine needs extra fuel and extra air also to provide a suitable mixture and increase idle speed. When the engine is cold, an auxiliary air valve lets air bypass the throttle plate. As the engine warms up, the valve gradually closes. This keeps idle speed fairly close to the basic setting of the idle speed adjusting screw, which is on the throttle body. Another method uses an idle speed control valve with the bypass passageway controlled by the ECU. The passageway is varied for cold starting and if the engine has extra loads, such as headlights or air conditioning. A predetermined programmed idle speed can thus be maintained. Variable inertia manifolds can vary the effective manifold length in 2 or 3 stages to extend the torque curve over a wider RPM range. Generally, long intake pipes improve cylinder filling and therefore engine torque at lower engine RPM. Shorter pipes improve cylinder filling at higher RPM. Cylinder filling can also be improved by using engine-driven supercharging and by turbocharging. In throttle body systems, the air supply is led from the air filter into the central throttle body system. Here the air mixes with the fuel from the injector or injectors, and the mixture is carried through the manifold pipes into the cylinders. Manifold design, however, is usually a compromise in order to keep the mixture vaporized. Heating the manifold by engine coolant is necessary, and the pipes tend to be smaller in cross-sectional area. This tends to limit the advantages of EFI compared to a carbureted system, but useful gains can still be achieved in power and in reduced emissions. As in a multi-point system, air entering the engine must be measured. This, together with the engine speed signal, provides the ECU with the basic information needed to determine the pulse width of the injector.